about finding a confidence interval in the formula we're going to use to find the confidence interval for. There are technically two formulas, but we're pretty much going to use only the one for standard deviation. So I would save time and only put this one on your formula sheet that you get to make. And it says that the confidence interval is going to start with this left-hand side. This has already figured in the error. It's already doing this behind the scenes. Is that you're going to take your n-1 first, which is your degrees of freedom, and multiply by your s squared, which is your sample standard deviation squared. Then you're going to take your chi-squared on the right, your critical value from the right, and divide by that. You're not squaring it. It's already a chi-squared value. You're just going to divide by it. And then you'll take the square root at the end. Now, I do want to say this because I think that most students think that there's some kind of typo here, and it's not. Yes, the chi-squared from the right side of your picture actually goes on the left side of your interval. That is on purpose, because your interval should always go from smallest to largest, and if you don't do it this way, you'll get it in reverse. So this was written right. I am not making a typo here. The right-hand side is almost the exact same. You're taking your degrees of freedom, your n-1, times again your standard deviation for the sample s, squaring it, divided by your chi-squared value, but this time your chi-squared value from the left side of your picture. Then after you do all of that math and do your division, you'll take the square root at the very end, and that will be your ending value for your confidence interval. So let's take a look at how to use this formula by looking at an example. However, what does this mean I need to do before I do anything? Is I need to find my chi-squared on the left and chi-squared on the right, which means I need to start by drawing my picture. How do I know I'm going to be even using chi-squared when you look at your problems on a test? It's because you'll be constructing a confidence interval for the standard deviation. When you're doing any kind of testing or confidence intervals for the standard deviation, you're always going to be, that's your dead giveaway of how you're going to be knowing that you're using chi-squared. So let's draw our picture. Remember, start by doing your axes because it starts at 0. Draw your mock-up, and let's draw in what we're trying to find, which is a chi-squared on the left and the chi-squared on the right. Now, on this particular problem, how we're going to fill it in is just like before. We need our confidence level, which is 99%. That's what's going to fill in our middle section here, which tells me that this middle section is going to get filled in with what value? It's going to get filled in with 0.99, which means that the other two ends are going to be the other 1%, or 0.01. But that's both of the ends together. So each one individually is going to have to be half of that 1, or 0.01. So if I take that and cut that in half, that means that each end is actually going to be half of that 0.005. And yes, they are always going to be the same area in both of the tails, even though it's not symmetric. It will work out like that each and every time. So let's find the chi-squared on the right first. Well, finding the chi-squared on the right first means I need an area to the right, which is that 0.005. I'm also going to need my degrees of freedom, which is my n-1. Well, my n was 41. So -1, that'll give me degrees of freedom of 40. So let's go use our degrees of freedom of 40 and our 0.005 to find our chi-squared on the right. Let's look at our table. So our degrees of freedom of 40, we'll use that whole line then, at least to start. And then at least on this first one, we need a chi-squared on the right, had the area on the right of 0.005. That puts us with our chi-squared on the right as being the following, the 66.7. 0.766. That's our first critical value for the one on the right, 66.766. So that's half of our issue of what we need to actually do the confidence interval. The other half is I need the area, or the chi-squared on the left. Well, let's see, that means I need the area to the right of its value, because chi-squared always needs an area to the right. So I'll need that 0.99 and the 0.05 added up. So we'll take the 0.99 added to the 0.005, and we end up with a 0.995 as my area to the right. So when I go to use my table again, I'm going to use 0.995. Still got the same degrees of freedom, which gives me a chi-squared critical value of 20.707. So that is my second critical value, my chi-squared on the left. And really, that's the only bit of background that I'm going to need to do before I start my confidence interval each and every time. So then I can start by writing out my formula and filling everything in to get the final computations. They both have a square root on them because we're talking about standard deviation, and they both start out with an n-1. They both start out with an s squared, and then they both divide by a chi-squared value, but it's reverse. The one on the left, you're dividing by technically the right chi-squared value, and the one on the right, you're going to divide by the chi-squared from the left. So, a little bit weird, but that's how it goes. So let's continue. So, we know that our n-1 is just a fancy word for saying what are your degrees of freedom. So we can go ahead and fill that in. Our n-1, our n was 41. So n-1, we used this on our picture, was 40. The s, we have to go back to the original problem to kind of see what our s was. Let's go see. That's our sample standard deviation. If you go back to your original problem, it says it had a standard deviation of 11.3 beats per minute. So I can go back, and that means in my formula, I'm going to use for my s squared a standard deviation of 11.3. That's just my standard deviation. They say they want it squared, so I need to square it. And then remember, next I'm going to divide by my two critical values. On the left-hand side, I'm actually going to divide by the right one, which is the 66.766. That's the one that was on my right. I'm actually going to divide by on the left. And the one on the right here is actually going to be divided by the left critical value, which was the 20.707. And then the most common mistake I see on the test is people forget to, whatever I get at the very end of this, don't forget, is that both sides we have to take the square root of those when I'm all said and done with everything. So one thing at a time. Let's worry about the square root at the very end. Let's figure out what's underneath the square root first. So, order of operations is going to make us do what first? Exponents. So we have to do our squareds first. So we'll do our 11.3 squared first, then multiply by the 40 that's out in front, and then divide by the critical value at the end. And then after that, we'll worry about the square root. So if we do our squared, multiply by 40, and divide by the critical value, we get under each side, under the first side, we'll get a 76.50. And under the other side, we will get a 246.66. And then we'll take our square root of both of these values at the end. The longer you can avoid rounding, the better, because you'll get a more accurate answer. And my math lab, we all know, loves accurate answers. So if we take our square root at the end, we got our 8.76. and our 15.71. And that is our official confidence interval for the standard deviation. Now, I just wanted to show you something and how this is set up. In this last one, we'll talk